This is example 12-11, the depth before a hydraulic jump, giving me the situation where we know the depth and the flow velocity after the hydraulic jump, and we're looking for the depth before the jump, and also what the head loss is within our hydraulic jump. So to do that, we can use one of the equations that we derived, right? We said 2 times v1 squared over g times y1 is equal to y2 over y1 squared plus y2 over y1. Now, what we don't know here is our y1, and we also don't know our velocity one. So let's maybe see a way of connecting those. So we can use continuity equation, right? We know that a1 times v1 is equal to a2 times v2, rectangular channel, right? So I have b times y1 times v1 is equal to b times y2 times v2, which I can of course solve for v1. So I have v1 is equal to y2 divided by y1 times v2. Now I can take this, plug this into my equation up here, and then we can see how far we get. So it'll be 2 times, now what do we have? We said v1 was equal to y2 over y1 times v2, all that squared, and then that is of course equal to, if we kind of spread that out, and we forgot to write the rest, missing part of our equation, divided by, of course, g times y1. So that would be 2 times y2 squared from in there times v2 squared, and then g times, now this is y1, we'll get y1 squared from up there, so y1 to the third power. And that is equal to, from what we see up there, y2 squared over y1 squared plus y2 over y1. And now we can start trying to solve this, right? Because the only unknown in here now is y1. So first of all, I think we'll just multiply by y1 cubed. So that we get 2 times y2 squared v2 squared divided by g is equal to y2 squared times y1 cubed divided by y1 squared. We can see that's going to start canceling out. And then y2 times y1 cubed divided by y1 also is going to cancel out. Right, so what do we get? We get y2 squared times y1, the 2 and the 3, plus y2 times y1 squared, 3 and 1. All right, so let's see. So we have a quadratic equation. And let's bring that into its normal form. All right, so we would get y2 times y1 squared. Then we get plus y2 squared times y1 minus this whole thing right here. 2 times y2 squared v2 squared divided by g is equal to 0. Now we can divide all this by y2. Give us y1 squared plus y2 times y1 minus 2 times y2 times v2 squared divided by g is equal to 0. This is like a simple quadratic equation, right? So we can write the solution. We can say y1 is then equal to minus y2 plus minus square root of y2 squared minus 4 times minus 2y2 v2 squared divided by g. All this is under the square root, and all that gets divided by 2. Or that's just that regular quadratic formula. So we have the negative signs that kind of cancel out in there. So we'd have minus y2. Now, if this, that we know that the square root has to be, it's going to be a positive number. So we don't really have to take this negative sign into account anymore, because that will give us a negative solution and we need a positive solution. So this has to be positive, so we don't have to plus minus, we can just do plus. y2 squared minus plus 4 times 2 is 8. 8 times y2 v2 squared over g. All this divided by 2. Plug in numbers. Equal to minus 3 meters plus square root of 3 meters squared plus 8 times 3 meters times 1.5 meters per second, all that squared, divided by 9.81 meters per second squared. Close that square root, divide everything by 2. That gives me 0.40424444 meters, or 0.404 meters if we want to round to 3 significant digits. There's our y1. So that's our depth to start out with. Now, good that it comes out that our depth is less at point 1 than at point 2, right? Because this has to be supercritical, that has to be subcritical. So that's good. So the last part that we have to do is find the head loss. For that, we have the equation that the head loss is equal to y2 minus y1 raised to the third power divided by 4 times y1 times y2. For us, that means 3 meters minus 0.402444 meters, third power, divided by 4 times 0.404244 meters times 3 meters. And that gives me 3.6055505 meters, or 3.5 meters if I have to round it. All right, so with that, we found what the head loss is in a hydraulic jump, and we also found what the height was before the jump. And this was all example 12-11.